Good morning, students. In the previous topic of physics, we have learned about the physical quantities and measurement. That was your chapter 1. And in chapter 2, we have seen that what is motion and its different form along with speed, weight, and density. Now we are moving ahead with chapter 3, energy. In this, you will learn the definition of energy, how the energy is expressed in proper units. Then we will discuss about different forms of energy. Then describe conversion of energy from one form to the another in different situations. Then state law of conservation of energy with examples. So now let's take our first topic, and that is definition of energy. Before going on to the definition, we will first see that what is work. When a force is applied on a body and a body tends to change its position in the direction of force, this process is called work. For example, so now let us take a block and let's apply a force on the block, suppose in this direction. And if a block moves into the direction in which the force is being applied, then this is called work. So the definition of work done is when the force is applied on an object and it displaces the object into the same direction, then the phenomena is called work done. So now let's take another block and apply a force in this direction, and suppose a block moves into another direction. So can you say that the work is done over here on this object? The answer is no. So now some can say that we have exerted a force and the object is displaced. So there is some sort of work that is being done. But this is not a proper explanation. Here the explanation is the work over here is zero because the force applied in some another direction and the object is displaced into some another direction. So the work over here is zero. Let us now see the formula of work. Work is equals to force into distance moved in the direction of force. The SI unit, from here we can get the force is having a SI unit Newton and the distance SI unit is meter. So unit of work will be Newton meter, or it can be also written into joule, or it can be also written as 1 joule is equals to 1 newton into 1 meter. So now with the help of definition of work, we can define the energy. So the energy is the capacity to do work. Understood? The SI unit of energy is joule, in which your work is being measured, or it is also having a SI unit calorie, and it can be also written as 1 calorie is equals to 4.2 joule. We can also write like this way: 1 kilocalorie is equals to 1000 calories. Now we will see work energy relationship. A body possessing energy is only capable of doing work. For example, if a person is hungry, he does not have much energy, so he cannot do much work. But after taking food, the person gets energy, hence he can do a lot of work. From this, we can conclude that if a body does not have energy, it cannot do any work. Now, a body possessing greater energy is capable of doing greater work. Whenever work is done by a body, an equal amount of its energy is used.